Hey everybody, welcome back to Young Engineers of Today. I hope you all had a good weekend. And I hope you're ready to continue with the bookshelf, except we're going to take a bit of a different tack. Now I want to ask you guys, show of hands, how many of you do not have a Windows machine? Okay, so we got one hand. All right, how many of you do have a Windows machine? Okay, just wanted to double check. Okay, so here's the deal. We can move on to something called vcarve, and I probably would only take like a couple of lessons to show you computer running Windows. Um, I would probably only take a couple of yeah. No, I've seen it before. I'd probably only take a couple of lessons to talk about it, just because the free version uh, doesn't exactly cooperate with this bookshelf design. So it would be an imperfect um, transition. So what I'm thinking is I might spend a lesson or two talking to you guys about vcarve and showing you guys how it works. And then I would actually show you guys how to set up the cam, basically all the toolpaths and everything like that for this bookshelf in Fusion 360. Because Fusion 360 has a built-in cam function in it. Now, the dilemma I'm coming into is what order to do this in. I'm thinking we might as well continue with the, sorry about that. We might as well continue with Fusion 360 for this lesson, just so just so we can, continue with that train of thought. And then once that's done, we'll spend some time working with vcarve. Um, because again, it's not going to be able to really take in the bookshelf design neatly and work with it perfectly, and it'll be a bit of a wreck. And that just has to do with the free version. Now there could be excuse me, it could be better with the paid version. Um, but I'm not about to ask you guys to pay for the software necessarily. This is not that's we try to do that. We try to avoid that at pretty much all costs when it comes to young engineers, because I mean, having you guys pay on top of actually paying for the classes, well, that's a little bit much. You shouldn't have to worry about that until you get to college, um, where you have to pay for the textbooks on top of paying for the classes and any other software that they have. So what we're going to do, I'm thinking now, is we're going to spend some time um, messing around with the cam side of Fusion 360, getting the toolpath set up for cutting the bookshelf out using something like a ShopBot or another mill or something like that, and then we'll spend a lesson or two looking at vcarve. So hopefully it should still be interesting and insightful and informative and all of that other good stuff, and at the very least provide a little bit of insight as to how something like this is done. Uh, so I'm going to go ahead and I'm going to get Fusion 360 opened. Also, on top of that, if things start acting wonky in the middle of this lesson, I do apologize. My hard drive is dying. I have a new one on order. It should arrive here by Wednesday, in which case I will be back up and running in fighting shape, and it'll be like nothing ever happened. But until then, there might be some technical weirdnesses. I've actually narrowed it down. That was the reason why I've been sort of running into technical issues over the last couple months, is because my hard drive has been slowly dying. Hello, Mateo. So, good news, everyone. Hooray. Just waiting for it to get started. It's doing that in its own time, taking its sweet time, like it always does. If I were a richer man, I would have an SSD to put this onto, but I'm not, and I don't. And so now we're waiting for it to do this, which is fine, because, I mean, like, it's hazarding it. Yeah, sorry, you missed my whole explanation. We were going to move on to vcarve, but the free version of vcarve doesn't exactly play nice. So I'm going to spend a couple of lessons talking about vcarve, but first I'm actually going to finish with the CAM side of Fusion 360, just so you guys understand what exactly CAM software does, what its point is, and then we can spend some time talking about vcarve. We're not actually going to be modeling anything else in Fusion 360, so you're not going to be developing the bookcase anymore. The bookcase at this point should be done, and it will be, at this point we'll just be creating toolpaths for it. Equals 75x equals 12.06. Well, there you go. Excellent. All right, so let me go ahead and open up my bookshelf. My bookshelf. So I've got a bookshelf opening up. Here we go. We can verify that it is in fact still embedded within our stock. Well, we are. We're not adding to the model at all, but we're creating a set of toolpaths for a CNC machine to cut it out from a piece of wood. So it would know exactly what it would need to do in order to cut that stuff out. Yeah, but we're not like adding more shelves or tabs or slots or anything like that. Like that stuff isn't happening. So, okay. Yeah, quick check. We can verify that it is in fact still embedded in the stock. Yeah. Which is perfect, exactly what we want. It is still within the dimensions of the stock. Not that that should have changed, but it's always good to make sure. And then what we can do is, let me go down to the slide that talks about what we're going to be doing next. Oh, should we be adding dog bone fillets? No. Yeah, sorry. There seems to be something going on with my internet connection. We're not going to be adding dog bone fillets, so we're going to skip all of that business. We're actually going to move straight to the CAM step. So yeah, this is going to be the CAM stage. This is probably going to take us this class, and then we'll spend maybe Wednesday and next Monday talking about vcarve. So we'll sort of play it by ear as we go along, and get as much information to you guys as we possibly can. So a CAM step basically simulates the tools that we would use to cut this bookshelf out of a stock. Am I sure about what? Okay. So yeah, we can affect different things like the method of cutting and tools and feed rate and other parameters, basically set up our cut without actually turning on a single machine. Basically simulate everything so that we can do the best possible job we can with the CNC machine as soon as it actually brings a drill bit or a mill to real-life wood. In essence, we want to simulate as much as we can before we actually start cutting so that we can be sure that it's being done correctly. Because anything we change here will, in fact, affect our final product and how quick or precise our final cuts will be. I'm not sure, Cohen, to be perfectly honest with you. I had a feeling that you guys would, but I couldn't be entirely sure anymore. So I guess we'll see. But anyway, we're going to go ahead and enter into cam mode right here. And basically all I did was I just went into Fusion 360. You can see on the very left-hand side right here, there's the word model with a little downward arrow next to it, and it's a darker button than the rest of the toolbar. I just clicked on that and selected cam. And it looks like not much has changed, except if we look at it, we've got cam root, we've got bookshelf, units, millimeters. Let's go ahead and change that to inches, hit OK. If we go back to the model, yep, it's still in inches. Now, you'll notice that I had to change the units from millimeters over to inches, even though in the model area it was set up in inches. That's because these are considered two separate workspaces by Fusion 360. They don't carry preferences from one over to the other. And that's just to basically make sure that you're, what's the word that I'm trying to say? It doesn't want to assume that you want to keep all of the options the same. You might want different options for the cam stage. You might be working with an end mill that, cuts in millimeters and designing a bookshelf that is in inches. So for that reason, you wouldn't necessarily want that kind of stuff to carry over. It doesn't assume, because that's what computers do. They don't assume because they can't. They're not able to. But the browser has changed, as well as all of the toolbar options that we have at the top. So now we've officially gone into cam mode, which is different from the modeling mode, which will allow us to set up our cuts. We already changed it from millimeters to inches. The other annoying thing is that the user presets that we made at the very beginning of this whole journey with Fusion 360, ply and width and all that stuff, that's only been in model mode. That doesn't carry over to cam mode, which is annoying, but it's okay. So what we're going to do is we're going to get started with a new set of cuts. We're going to go up to Setup, and then New Setup. As you see, defines a number of general properties for a set of machining operations. You can specify the work coordinate system, stock geometry, fixtures, and machining surfaces. So I'm going to go ahead and select this one. And we're going to get this nice yellow box around everything, and it's got the axis over here, and we got our regular window. So there's some stuff we have to do here. So this is the new model menu. And what we have to do is we have to set it up so that we've got, did it? What happened to this? All my explanations are gone. Oh well. So what we want to do is we want to set up orientation to be select z-axis / plane and x-axis, and the z-axis is going to be this edge here. And the x-axis is going to be this edge here. No, that's not it. There we go. That's what we want. Okay, so this requires a little bit of remembering it on my part. So orientation by default is model orientation, correct? And so you've got the axis. You've got the axis directly in sort of the center on the short edge, which is not ideal. That's actually not where we want it because that determines the start point for CNC machines. A CNC machine will assume that the corner of your material is right here, which is clearly not. That's the middle of that one long side, or that one short side, and so we really only be cutting half of we actually wouldn't be cutting any of our bookshelf because it moves in the directions of the arrows. So none of this overlaps with any of the bookshelf. So we want to make sure that we are aligning our axis so that it can cut the model for us. So we're going to select the z-axis, plane, and x-axis as opposed to model orientation because it tried to assume with the model orientation and that was not in fact correct. So for the z-axis, what we need to do is we need to select some vertical edge on our model. So I'm going to go ahead and select just this vertical edge here. It can be any of these vertical edges as long as it's one of them. The reason for that is basically it's figuring out that the z-axis is parallel to that particular edge that I selected. It was a vertical edge, the z-axis is vertical. That's excellent. That's exactly what we want. And then the x-axis we set up to be along the long edge. So now we've got the x-axis along the long edge, the y-axis along the short edge, and the z-axis pointing straight downwards, which is not exactly perfect. It's not exactly ideal. So what I'm going to do is I'm going to click z-axis here, flip z-axis, and what that does is it flips 180 degrees. We've still got the x-axis along the long edge and the y-axis along the short edge, and then the z is now pointing straight up, which is exactly what we want. 1 moment. Anyway, then finally for the origin, we're going to select a point for the origin, and we're just going to go ahead and select, it's not allowing me to select it, model origin. We're just going to go ahead and select the corner that allows this axis to cover the entire model. So hopefully that made sense. Go ahead and raise your hand once you've done that. Let's see, we have a new name in here. I'll give everybody a couple of minutes to sort of work through that. I know it's sort of a weird it's a weird dialog box and a weird way to set everything up, but it'll hopefully make sense in a minute here. And remember, just go ahead and raise your hand once you've finished. Give everybody a couple more minutes. Okay, so that's pretty much everybody's hand. Let's go ahead and move on to the next step. So we're still inside of the setup screen. Under stock, we're going to have a fixed sized box. So that's going to determine the size of our stock. We want to make sure that it remains the same size. So we'll go ahead and we want the width to be 48 inches. And then we want the depth to be 24 inches. Finally, we want the height to be 0.25 inches. So this, we're actually setting it to the same dimensions as the stock in our model, which is great. That's exactly what we want. Once that's done, hit OK. Just double check a thing. Okay, we'll go back into the cam mode. All right, so that should be our words. Our setup so far. Now, under this setup, we're going to have to create cuts. Basically, what this is doing is this is setting up a sort of a starting point and an initial conditions for all of our cuts. And then we need to add the actual cuts. They're sort of like steps in the process. So you can imagine it like a set of instructions with, or like a recipe or something like that, with the initial ingredients being the setup. So we need, all of this stuff in order to start working and making the thing that we want. The measurements were the same as the stock we were using in the model. So it's going to be 48 inches wide, so along the x-axis. It's going to be 48 inches long, so along the x-axis. It's going to be 24 inches deep, so along the y-axis, and then it's going to be 0.25 inches tall, so along the z-axis. 48 by 24 by 0.25. And yeah, once that's done, just go ahead and hit OK. So then we can go into the 2D cuts. Now, the handy thing about this particular model that we're cutting, for the most part, we can do nothing but two-dimensional cuts. The difference between two-dimensional and three-dimensional cuts is two-dimensional cuts assume that you are just cutting entirely through the material, all the way through, like using a pair of scissors on a piece of paper, in essence. Like, you don't have to worry about how deep you go or anything like that. A three-dimensional cut, you can think of like using a chisel and marble. You have to worry about how deep you cut something out, as well as the shape of the cut and things like that. So it's not necessarily as cut and dry, no pun intended, as a two-dimensional cut, but it is it allows for more nuance and more general kind of control. But two-dimensional cuts are certainly simpler, and again, for the most part, we're going to be working with two-dimensional cuts, which makes things nice. So what I'm going to do is I am going to go ahead and select 2D pocket. What that does is that creates pocket cuts. It allows you to cut pockets in. We'll go ahead and select that. And it's going to ask me to select my tool as well as the coolant. This is basically the type of stuff that is used to cool down the tool. I mean, as you might imagine. I don't know off the top of my head. I'm guessing air, though. I don't think it actually uses any sort of liquid in order to keep the tool clean. If it uses anything to keep the tool clean, it might be easier to assume that there is no cooling, but I think air is probably a pretty safe bet. So now I got all these settings here: spindle speed, surface speed, ramp spindle speed, cutting feed rate, feed per tooth, lead in feed rate, lead out feed rate, ramp feed rate, plunge feed rate, feed per revolution, blah, 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 blah. Like a whole bunch of different stuff. We don't have to worry about this exactly at this moment. I will spend some time talking about what exactly all of those are. But we will look at the tool. So I'm just going to go ahead and click Select on Tool, and you get this dialog box, which is a whole bunch of stuff. We've got a whole bunch of stuff. We're actually interested in probably, well, let me see what we got up the top here. Aluminum will work. Now, the size of the tool is going to be important because we are working with 1/4 inch margins. A lot of our stuff is going to be separated by only 1/4 of an inch. That is to say, these holes here are 1/4 inch wide. They're, what, 3 inches long, but they're 1/4 inch wide. This area right here, between these two walls, probably about 1/4 inch, maybe not even a little bit less. The blind tab pockets are going to be 1/4 inch wide. So, you know, we have to make sure that we're selecting a tool that is smaller than that so that it can actually cut out those areas. If it can't cut out those areas, well, our tabs aren't going to fit very well at all. So we want to make, again, that's why we want to make sure that we're using a tool that is smaller than those cuts, because it can actually cut that stuff out as opposed to just sort of mash itself in there and then, you know, create a, I don't know, a 3/4 inch wide hole. That's, the tabs aren't going to fit in there. That just simply will not work. So let's take a look at all the tools we got here. We've got a 1/16 inch diameter. That's what that little symbol means. That means diameter. 1/16, 1/16, 1/8, 3/16, 1/4, 5/16, 3/8, 1/2, 5/8, 3/4, 1 inch. So once we get here, this stuff starts to get like way too big. However, we also don't want it to be too small because it has to actually cut through all of that material. So we could do something like a 1/16 of an inch, 1/16 of an inch end mill head, and that would certainly be the safe option. We could guarantee that we are actually going to cut out the holes and everything like that. Unfortunately, it would also mean that our cut would take a very, very long time. So we might be better off going a little bit larger. In this case, we might do maybe a 3/16. It's got a, you know, a flute length of a little bit over 1/2 inch, which would certainly be, you know, large enough to cut through our entire ply. Again, the diameter of the shaft is 3/16. And we've got a whole bunch of other stuff here. So we've got surface speed, 490.87 feet per minute. feed rate of 45 inches per minute, a spindle speed of 10,000 RPM, feed per revolution of, what is that, 4 thousandths of an inch, 4.5 thousandths of an inch. Whoops. So let's go ahead and we'll go with a 3/16 flats. We'll just hit OK. And as you can see, this stuff actually automatically updates. So we got a spindle speed of 10,000, a service speed of 490.874 feet per minute, a ramp spindle speed of 10,000. It's got some default values that it automatically populates these things with that you can then later on change to your heart's content. In fact, we're actually going to, it automatically populated that with flood, so we're going to change it to air. And then take a look at what each of these things does. Now, spindle speed is how fast the tool itself actually spins. That's all that is. Same with ramp spindle speed. The reason why they're different is ramp spindle speed refers to actually getting, like for instance, for a three-dimensional cut, or cutting through thicker material, it refers to making some initial cuts before it actually goes all the way through the material and then does like a regular two-dimensional cut. So again, think of, imagine you were cutting a cake with a knife. You were cutting like a, okay. Imagine you were cutting a cake with a power drill. Just because that's a great mental image. Imagine you were cutting a cake with a power drill. Now imagine you needed to sort of make some initial cuts. Like you couldn't just send the power drill all the way through the cake first go. Like you couldn't just pull the trigger on the power drill and just go straight to the cake and then start cutting across, because let's say you have a terrible power drill and let's say this cake is surprisingly hard. You might want to make some initial cuts, go in like a quarter of the way into the cake, come back out, let the power drill, cool off or relax for a second, go another quarter of an inch into the cake, pull the power drill back out, sort of make gradual progress each time. That's kind of like what the ramp is. The ramp allows you to make gradual progress into a material in order to avoid overheating the tool, overheating the material, breaking the tool, all kinds of bad stuff. So you can have a different spindle speed for ramping in order to ensure that you make, good headway on the material cutting into it without actually damaging the tool. So that's the spindle speed. It's just the rate at which the tool spins. The cutting feed rate is the rate at which the tool will basically make progress across a material. The higher the feed rate, the faster the tool actually moves across the material when it's making its cut. So again, in our power drill example, the spindle speed is how fast the power drill spins, and the feed rate is how fast you move the power drill through the cake. Still an entirely ridiculous analogy, but it makes sense. Feed per tooth is basically how far the tool moves through the material for each time the tooth makes basically a bite into the material. So as you can see, it's a very, 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 very small amount. It's 1.5 thousandths of an inch, and that's because it's spinning 10,000 times a second, and it makes progress across the material at a rate of 45 inches a minute. So for each time the tooth just basically makes a rotation and bites through the material, it's moved forward 1.5 thousandths of an inch. The lead-in, lead-out feed rates are 45 inches a minute. Again, that has to do with ramping. Plunge feed rate is 30 inches a minute, and the feed per revolution is 3 thousandths of an inch. But we're not really going to be worried about that too much. Now we're going to move on to geometry. Geometry is basically where we select what is going to be cut in this pocket mode. So let's go ahead and just, since it's a two-dimensional pocket cut, what we can do is we can just select a whole bunch of stuff, like all these tabs, or excuse me, all these slots for tabs that are going to be cut by the tool. Now notice I am not selecting these slots down here. I'm just going to move past them. Whoops. Oh no, I accidentally selected a side instead of a pocket, so you want to be careful about that. Don't be a dingus like me. All right, so what you want to do is you want to select, see how when I put my mouse over this, I'm actually getting the line that's around I'm getting the edge of the slot. I can go ahead and use pocket selection. Use that for my pocket selection. And again, you want to be careful of that. Notice how I move the cursor down here, and suddenly I get the edges of the sidewall of that slot. I don't want that. I want the top of the slot. So we're selecting all of the slots that go all the way through the walls of the bookcase. We're not going to be selecting these blind tab slots for the top of the bookcase because those are going to be three-dimensional cuts. Now I'm going to click on this tool orientation, and as you can see, we're taking a look at where the tool is going to cut through. We want these arrows to be on the inside of the pocket. That is actually very important. If they're on the outside of the pocket, that means that they're going to cut everything out around these slots. So it's actually going to be the reverse of what we intend. So we want to make sure that these arrows are inside of the slots. We can just rotate things around in order to double check. Viewing it from the top, we can much more easily see that these arrows are in fact inside of the slots. Which is excellent. And we're going to check out clearance/height. This is fine. This is just something you don't really have to worry about most of the time. Passes. We can see if we have any stock to leave. We're not going to leave any stock because we want to cut all the way through. We've got a tolerance of 4/1000ths of an inch, which is about, I don't know, about a sixth. Less than a sixth, much less than a sixth. It's 1/60th, roughly, of these actual cuts, which is a very, very good tolerance. And then under linking, we're gonna, not have any pre-drill or ramping. We can just set ramping to be straight up plunge. Just makes it super easy. Basically, stick the power drill directly into the cake because we're dealing with a strong tool and we're dealing with some soft wood. So we don't really have to worry about, breaking the tool by just cutting into wood. If we were dealing with super hard wood, if we were dealing with metal or a hard resin or something like that, we would want to make sure that we're actually, ramping into it, doing some pre-drilling and ramping into it as opposed to just sticking the tool directly in there and making our cuts. But again, we're not really going to be worried about that. We're not going to have any leads and transitions. And we're just going to hit OK. And it's going to spend some time calculating cuts. You get a little percentage next to it, and then you get a picture of the tool with some lines. And this is a simulation of the path that the tool would take in order to do these cuts. If we wanted to, we could go up to Actions over here and then Simulate, and click on that. And we can click the play button here, and it shows us exactly what the tool is going to be doing, which is pretty cool, right? And we can control the speed of the simulation. We can actually make it go backwards, or we can make it stop, go forwards very slowly. Watching this, now you'll notice that there are some red areas here. The red areas basically mean that they're high stress areas for the tool. However, we haven't gotten any errors yet that these red areas are causing a problem for us, so it's not we're not going to worry about it until we get an error from Fusion 360, essentially. But generally, you want to make sure that these lines are either blue or yellow, but ideally like blue or green. Yellow is fine too, because yellow usually also means that it's not making a cut, it's just going through a general area. But these blue areas mean that basically the tool is going to be okay. There's no, is this actually going to go any, oh, okay. The tool's going to be okay. It's not going to cut anything it's not supposed to. The feed rate should be okay considering what we're trying to do with it, that sort of thing. So that's cool. I'm going to go ahead and click close. And that's the first set of cuts that we're looking to do with a CNC machine. Now, we want to do 2D Pocket again. You might be going, why do we want to do 2D Pocket? Well, because we actually have to cut the actual pieces of wood out from the stock, right? So let's go ahead and again check the position of our arrows and make sure that they're on the outside of these materials. Basically, wherever the arrow is, that material is going to be cut away. If it's got this dark blue, that means that material is going to be cut away. So we want to make sure that these arrows are on the outside of each of these parts of the bookcase and that the areas around the outside here are dark blue. Everything else should more or less be the same as it was before. Unfortunately, it didn't save the ramp or the leads and transitions, of course, again, because it doesn't want to assume that. But we're just going to change it to plunge, and we're going to keep everything else as is. And also uncheck stock to leave, hit OK. Again, we'll get a percentage over here, and bam! Now it's figured out that, hey, there's a whole bunch of stuff to cut away from the outside. We can go in our simulation and watch it do its thing. Speed it up a lot. It's spending a lot of time cutting away a whole bunch of extraneous material. That was the sound of the cutter freaking out. And actually, that's, I believe, because of an error I made. Let me go ahead and come back to this one and edit. We are going to leave some stock. And we'll see how that changes everything. Nope, doesn't change a thing. That's fine. But that's going to do it for today. On Wednesday, we will finish with the cam portion of this because actually, believe it or not, there's really not that much left. And then I will spend some time introducing you guys to VCarve and going over that whole thing. Now I know not everybody has a Windows computer. I'm going to try and get you guys who do have a Windows computer to download VCarve so at least you can follow along with me. But if you don't have it, don't sweat it. Just, I guess, just watch the lesson. And then we can move on to something else after that because it shouldn't be too terribly long. But honestly, we're on the home stretch now. We're almost there. We're going to get through as much of this as we can on Wednesday and, spend some time with VCarve, getting you guys familiarized with it, and then we'll move on to a new subject probably later next week or early the week after that. So I'm going to go ahead and do the poll questions, and then we're going to go ahead and leave it open for question and answer time. And if you don't have any questions, you're more than welcome to head out. So here we go. Without further ado, the first poll questions.